In this video, we'll look at a procedure for finding duplicates in an unsorted array. I have an example array. Here the elements are not sorted and there are some duplicate elements present here in this array. Like 8 is appearing 2 times and 6 is appearing 3 times and the rest of the elements are unique. Now I want to write a procedure, find out duplicate elements, and also I want to count them, how many duplicates are there. So there can be more than one solutions. So first solution let us look at. We will scan through an array, we'll pick up an element and look for its duplicate. Like 8, we will check in the rest of the array and find out is there any other 8 present in an array. Next we'll pick up 3 and check in the rest of the array to find if there is any other 3 present in an array. So I will demonstrate in this list. So for demonstration, let us take one variable count and initially let us say count is 1. Now start from here. This element I am counting it for 1 time. Now from here I should check in the rest of the list, is there any other 8? So for that I can take one more variable, that is j. With the help of this variable I will scan through this list and find out if there is any other 8. So let us start. Is it 8? No. Move j to next location. Is it 8? No. Is it 8? Is it 8? No. No. Yes, it is found. So once it is found, 1 to this. So now we have 2 8s. Continue. So is it 8? Is it 8? No. So we have finished looking for a duplicate of first element 8 and we found 2 elements. So count is 2 means yes, there are duplicates. Already we have taken that 8 into count. So we should not count it again. It may happen that the same element is counted multiple times. So we will see that situation. So for that we should remove that 8 or we should have some marking to show that that is already counted. So for that I will take -1 in this place. So whenever a duplicate is found, just mark it as -1. -1 is element is not there. Alright. Now let us continue. We will find the duplicates of other element. Then I can explain you what is the reason of taking -1 once again. Now start. I will find the duplicates of next element 3. So make this as count as 1. Now using j, go on looking for 3. 3 is not there. Now take j from here and go on looking for the element 3 by comparing the elements. Next. So 3 is not there. So count remains 1, means there is only one copy of 3. Now let us take the next element 6. Now here I am at 6. Now start finding 6 using j. Is it 6? No, it's not 6. So move j to next. Is it 6? Yes. So count. Then again move to next. It's not 6. This is 6. So count. Then this is -1. Leave it. It's not same. So this is 2. This is 7. I have came across 2 more 6. Right? I am finding the duplicate for this one. So I should mark this as -1. Yes, -1. Now count is more than 1. So it means there are duplicates of 6. Next, let us go to the next element. For 4, if I find in the rest of the array, there is no other 4. So count remains 1 for 4. Now take the next element. Now the point is, shall I take this element or not? If I take this element, then again I will get the result that 6 is appearing 2 times. I should not take that element because already it is counted. Leave it. So it's a duplicate element. So I have marked the duplicate elements. Otherwise, I may be getting duplicate results. Otherwise, I may be getting extra results that for 6 it appear 3 times. Again from here 6 appear 2 times. So that is the reason I am marking them. So this is the procedure. Now before showing you the program code, let us do some analysis. How much work we are doing. See, we have started finding a duplicate element of 8 first here. So for finding duplicates, I am comparing with the rest of the elements. So if there are total n elements, then how many elements I am comparing? n-1 elements I am comparing. Then again, being on 3, I am comparing the rest of the elements, right? I don't have to check on this side. I have to check the rest of the elements. So total how many? n-2 elements I am comparing. Then being on 6, I am comparing n-3 elements. So n-3 comparisons I am performing. Then same way it's go on reducing up to last 3 comparison, 2 comparison and 1 comparison. So these many comparisons I am doing. So total how many comparisons are these? These are n into n minus 1 by 2. N into n minus 1 by 2. So this is n square minus n by 2. So the degree is n square. So it is order of n square, or big O of n square. Though we don't know what is big O omega, so let me call it as order of, that is, so I'll be simply calling it as order of, that is degree of 2, that is n square. Degree is 2. So it is order of n square, right? Now let us look at the procedure. So I will write on the procedure for this one. For finding duplicate, I have to start finding the duplicates of the first element. So I should start from here. So one is I, that start from 0, and I should stop here because I don't have to check for the duplicates of this element. I should stop at this point at last. So that is less than n minus 1 I plus plus. Right? So this is the main loop that is going through all the elements to find their duplicates. Then every time I should start count with 1. Okay, count with 1. For every element, count as 1. Then find are there any more elements to increase the count. Now when I is here, I have to scan through the rest of the list, right? So I am starting J from here and continuing till the last element. So I will take one more for loop for this J, that is J assign I plus 1, that is next element of I, and it should go till the last element, so it should be less than n and J plus plus. Then what I should do, like for 8, if I have reached here, means the element is matching. So I should compare this element with this one, and if they are matching, I should increment count. So here I will set if A of I is equal to A of J. If they are equal, then I should do count plus plus. Yes. Then, as I said, also I should mark this as minus 1. So at A of J, I should make it as minus 1. So count plus plus, J minus 1. Then end of this loop. Now once I come out of this loop, I should check what is the value of count. If count is greater than 1, then means there are duplicates. So here I will write down printf if count is greater than 1, then print. So here I am printing percentile D. First is A of I, that is 8, and count means how many times it is duplicated. So this will print this one if count is greater than 1, means there is a duplicate element and how many times it is duplicated, both I am getting. So end of this loop. Now one more thing, this checking for the duplicate I should do if it is not minus 1. So here I will write on the condition if A of I is not equal to minus 1. Means for this element I should not find the duplicates, right? Because already it has become minus 1. So for this one I should not do, right? I should not enter into this one. So this is conditional. So that's all. This is the procedure for finding duplicates and counting how many times each element is duplicated. Already we have done the analysis. Now let us look at the code and do the analysis. See, from the code, this loop is repeating for n minus 1 times, so almost n times. This will repeat for almost n time. And this is starting from I plus 1 till n. So this is also repeating almost for n times, right? We already know the working. Based on that we are saying that, right? It's not just by reading the code. We know the working. It's starting from I plus 1 till n. So this is also almost n times, right? Otherwise, if you want to consider in detail, this will be reducing one by one. N minus 1, n minus 2, n minus 3. So if I sum up, again it was becoming n square. So now roughly I am writing it as n. So this is n inside n. So there is a for loop inside for loop. So the time is n square. That is order of n square. So that's it. This is the procedure for finding duplicates. So you can try this by yourself. It's a student exercise. I have written the code on board. Just you have to write a main function, and inside the main function you have to declare this array and write down this similar code and see the results. Now let us look at the second method for finding duplicates and counting duplicates in a unsorted array. So this is using hash table. A simple hash table, or also you can call it as a bit set. So let us see the procedure. I have the same array here having duplicates, that is 8 is duplicated and 6 is duplicated. Now I have to take a hash table array, and the size of the array should be equal to the largest element in the array. So if you check in this array, the largest element is 8. So I have taken till index 8, means total size is 9, because starting from 0 onwards. Now the procedure is, I should scan through this list, and for each element I should increment the count here in this hash table. So let us do it. Start from first element 8. Go to index 8 here and increment it. Then move to next element 3. So go to index 3 here, so increment it. And 6, go to index 6, yes, increment it. 4, increment it. 6 again, so 6 should be made as a 2, I'll overwrite it. Then 5 is 1. Then 6, I will overwrite this one. This is 3. Then 8, this is 2. Then 2, this is 1. And 7, so this is 1. That's all. I have scanned through this array only once. Yes. So if I analyze how much time I have spent, order of n time. So I'll just write n. Now next what I have to do, I have to scan through this hash table wherever I got a value that is greater than 0. Yes, this is greater than 0, greater than 0. Yes, wherever I get the values greater than 0, element is present there. And if the value is greater than 1, then duplicate is present there. Like this is 1, so this is single value, 3 is single, 4 is single, 5 is single, 6 is appearing 3 times, right? 6 is appearing 3 times. And this is 7 is single and 2. So 8 is appearing 2 times. So I got the elements which are duplicate, and also how many times they are duplicated. I got both of them. And for scanning through this, let us say time is n, because actually n means here linear. Actually n here means it's linear, right? Linear. So this is linear list of elements, whatever the size may be. Don't check that this number of elements are different, this is different. If that is n, this is n minus 1. No. N means linear in simple terms, right? So this is also linear. So linear plus linear is 2 linear. So 2 linear is also linear only. So it's order of n. So 2 times of linear is also linear. So I will not write down the code, right? So already we have seen this in missing elements. So logic will be similar. You can write down the code for this one. So this is also a student exercise. So you can write on the main function, in that you can take this array and then write on the code for finding duplicates and also displaying their counts. So that's it in this video.